Good morning, everyone. Our topic today is all about hypothesis and conclusion. So let's focus on the chart that we have here in front of you. You got the key here. The green refers to the constant variables. The blue is the independent variable. Orange is the dependent variable. Okay. So if you're looking at the chart here, the green, these are constants. Constants refer to the variables that were not that are the same across the groups or between the control group and the experimental groups. The amount of salt solution added, the temperature for each setup, and the number of species X that were placed at the beginning of the experiment. They're all the same. So if you look at the number values here, they're same across the board. Okay, the blue, the independent variable, we only have one, which is the pH of the solution. That is the only material that was changed in the experiment. And then the orange is the number of species X that survived. At the end is the dependent. Dependent refers to your data. Since our topic today is about how to state the hypothesis, we will be following a specific format. Format is very easy to understand or to remember. If and then, okay? Remember, we always state the IV first. So if and then state the IV and then state the change. What kind of change? Did you add the IV? Did you remove it? Did you increase, decrease, or state whatever or however it works for your experiment? Okay, another way to remember it is the I. The I in the if could be used as your key that you're going to place the IV first, okay? The second part of the sentence here is the then part. Then part sounds like a letter D. So you're going to put the dependent variable following after the then. So state the DV and then state the change, whether it decreased or increased. All right, so let's look at your chart here. What is your IV? Okay, the IV is the pH of the solution. Now you can state the change in your IV. You can come up with your own description, whether you added it, you decreased, you increased. Look at how the experimenter manipulated the pH. There you go. So did you say it was added? Was it removed? Was it decreased or increased? Okay, you can see the pattern 4.5, 6.5, 7.5. So I think we all agree that it's increased, right? Here's your DV, number of species X that survived. Okay, you can state anything, increase, decreases. This is just a hypothesis or your guess at the beginning of the experiment. So this is how, or this is what we're going to get. If this is the IV, pH of the solution, and here's the change, increased. Then followed by the DV, which is number of species X that survives, followed by the change, decrease. So this sentence now is our hypothesis. If the pH of the solution is increased, then the number of species X that survives will decrease. Let's now move on how to state the conclusion. For stating the conclusion, we follow the format as D, then state the independent variable, followed by the change. The, state the DV, then the change, okay? It's very similar to the hypothesis in a way the hypothesis is if and then. Conclusion is as the and then IV then the DV. Let's look at the chart here and state our conclusion, okay? The orange codes for the dependent variable or the data or the result of the experiment. The blue, again, refers to your IV. Okay, let's look at the IV. What's the change in the number? 4.5, 6.5, 7.5. Is it increased, decreased, stay the same, or removed? Okay, so it's increased. So as you increase the pH of the solution, what happened to the number of species X that survived? Did it increase as you increase the pH, or did the number of survivor decrease? Okay, I guess you can see the pattern there, right? It's decreased. So let's now state the conclusion. The conclusion will be following the format as the. So we're going to have as the pH of the solution increases, the number of species X that survives decreases. That is going to be the conclusion for this experiment following the format that you've learned. Okay, finally, this is going to be an extra concept that you will learn from this video, is how to make sure that the experiment is valid. There are 4 concepts here that must be remembered. Number 1, an experiment is valid if there's only one IV, one test variable. So let's go back to our chart. Do we only have one test variable here? Look at the blue. How many blue do you see? I only see one here. So that means our IV is the pH of the solution. So I guess this experiment passes the test of having one IV. Second concept, it must have a control group. What's the control group for? The control group is for the basis of comparison for the result of the other groups, which refers to the experimental groups. Okay, let's look back at our chart again. How many control group, or do we even have a control group for this one? The answer is yes, right there. Control group is the one with the pH of 5.5. 5.5, according to the given, is the natural environment for species X. And the experimental group, we have 3 sub-experimental groups where the pH of the solution were changed. Okay? So that makes this experiment good for the second condition. Third condition, it must have a large test sample. Why? Well, if you only have one test variable and the experiment came out positive or good in terms of result, would you say it's really valid if you only tested one specimen or one species or one test sample? I guess not. So let's look at your data here. Is 10, this is your test sample. How many species X were tested? Okay. Is 10 a large enough number? Perhaps not. Not really a large enough test sample. Ideally, we use 100 or 1,000 in the real life experiment. Okay. 10 may not really be enough for a very authentic and accurate experiment. So that maybe can be improved for this example. Let's look at the fourth basis. The fourth one is repeat the experiment. All right, you got the first result good. Would it be valid enough to make a conclusion out of one experiment? Perhaps not really. So that's why sometimes, experiment or scientists would come up with another set of experiment to repeat it so that if they get consistent result, then they can jump into the conclusion that their experiment is valid. All right, let's look at the data here. Is this a one-time experiment? The answer is yes. Okay, this is only a one-time experiment. So that means in order for us to improve this experiment, well, we do have one control group. We do have one IV. The test sample is not really that big, so that we can improve. We can make it 100 or 1,000 or 500 or 250, as long as it's not on a 2-digit number or 1-digit number. And obviously, we can repeat the experiment. All right, so this wraps up our video on how to state the hypothesis and conclusion, and also an added concept on how to make the experiment valid. I hope you learned from this. Thank you.